Imagine you are measuring the height of all the students in your class. You line them up from the shortest to the tallest, and you start to notice a pattern. Most of the students are clustered around a certain height, which we can call the average height. As you move away from this average, you find fewer and fewer students who are either much shorter or much taller. This pattern is not just a coincidence, it is a common occurrence in many types of data. You would probably find that most students are around average height, forming a peak in the middle of your data graph. This peak represents the most common height range among the students. With fewer students being very tall or very short, the graph starts to taper off on both sides. This tapering effect creates a shape that is symmetrical around the average height. This natural distribution of data, where most values cluster around the average, is what we call a normal distribution. It is a fundamental concept in statistics and is often represented by a bell-shaped curve. Normal distribution, often illustrated as a bell-shaped curve, is a fundamental concept in statistics. This curve is symmetrical, with its highest point at the mean or average value. It helps us understand and analyze data in various fields, from predicting exam scores to understanding population trends. For instance, if you know that exam scores follow a normal distribution, you can predict how many students will score within a certain range. The bell curve provides a visual representation of how data is distributed, with the highest point of the curve representing the average or mean value. The spread of the curve indicates the variability in the data. This pattern of data distribution is incredibly common in nature and everyday life. For example, the heights of people, the weights of apples, and even the lengths of leaves on a tree often follow a normal distribution. Think about the lifespan of a light bulb or the distribution of shoe sizes in a population. These phenomena often follow a normal distribution, highlighting its significance in understanding the world around us. These phenomena often follow a normal distribution, highlighting its significance in understanding the world around us. By recognizing this pattern, we can make more accurate predictions and better understand the variability in different datasets. The beauty of the normal distribution lies in its predictability. Because it follows a specific mathematical formula, we can use it to estimate probabilities and make informed decisions. By understanding its properties, we can make inferences about data, estimate probabilities, and make informed decisions based on statistical evidence. For example, businesses can use normal distribution to forecast sales, and scientists can use it to analyze experimental data. Let's delve deeper into the characteristics of this fascinating statistical concept. We will explore how the mean, median, and mode are all located at the center of a perfectly normal distribution, and how the standard deviation helps us understand the spread of the data. The bell curve, also known as the Gaussian distribution, is characterized by its symmetrical shape. This shape is not just a random occurrence, it is a fundamental concept in statistics and probability theory. The bell curve is a graphical representation of a normal distribution, which is a type of continuous probability distribution for a real-valued random variable. The term bell curve comes from the fact that the graph of its probability density resembles the shape of a bell. Imagine a bell cut in half from top to bottom. That's the basic shape of the normal distribution curve. This curve is crucial in many fields, including psychology, business, economics, and the natural sciences, because it describes how data points are distributed in a dataset. The bell curve is used to model a wide range of phenomena, from test scores to heights, weights, and even IQ scores. The highest point on the curve represents the mean, median, and mode of the data set, indicating that these measures of central tendency all coincide in a perfectly normal distribution. This peak is the point where the data is most concentrated, and it represents the average value of the data set. In a normal distribution, the mean, median, and mode are all equal, which is why the peak is so significant. As we move away from the center of the curve, the frequency of data points decreases symmetrically on both sides. This symmetry is a key feature of the bell curve and indicates that the data is evenly distributed around the mean. The further you move from the mean, the less frequent the data points become, creating the characteristic tails of the bell curve. This means that values further away from the average are less likely to occur. In practical terms, this can help us understand the likelihood of certain events or outcomes. For example, in a classroom, most students will score around the average on a test, with fewer students achieving very high or very low scores. This concept is essential for making predictions and understanding variability in data. The tails of the curve, extending infinitely in both directions, represent the extreme values, which are rare but still possible within a normal distribution. These tales show that while extreme values are less common, they are not impossible. This is important in fields like finance and insurance, where understanding the probability of extreme events can help in risk management and decision-making. The symmetrical nature of the bell curve allows us to easily visualize and understand the distribution of data. This symmetry makes it easier to identify patterns and trends within the data, which can be crucial for analysis and interpretation. By understanding the bell curve, we can gain insights into the underlying structure of the data and make more informed decisions. For instance, if we know the average height of students in a school is 5 feet 6 inches, we can infer that most students will be clustered around this height, with fewer students being significantly taller or shorter. This clustering around the mean is a hallmark of the normal distribution and helps us understand the spread and variability of the data. It also allows us to make predictions about the population based on the sample data. Understanding the shape and characteristics of the bell curve is crucial for interpreting statistical data and making sense of the world around us. The bell curve provides a framework for analyzing data, identifying patterns, and making predictions. It is a powerful tool that helps us understand the probability of different outcomes and the variability within a dataset. It provides a framework for analyzing data, identifying patterns, and making predictions based on the principles of normal distribution. By understanding the bell curve, we can better interpret the data we encounter in everyday life, from test scores to financial markets, and make more informed decisions based on this understanding. While the peak of the bell curve tells us about the average, it doesn't give us the full picture of the data's behavior. The average, or mean, is just one aspect of a dataset. To truly understand the data, we need to look at how it is spread out around the mean. The spread of the curve gives us another important piece of information, the variability of the data. This variability is crucial because it tells us how much the data points differ from each other and from the mean. Without understanding variability, we might misinterpret the data's true nature. This spread, or how tightly the data points cluster around the mean, is measured by a concept called standard deviation. Standard deviation quantifies the amount of variation or dispersion in a set of values. It provides a numerical value that helps us understand the degree to which the data points differ from the mean. Standard deviation is a measure of how spread out the data is from the average. A low standard deviation means that the data points tend to be very close to the mean, whereas a high standard deviation indicates that the data points are spread out over a larger range of values. A small standard deviation indicates that the data points are clustered closely around the mean, resulting in a tall and narrow bell curve. This suggests that there is less variability in the data, and most of the values are similar to the average. On the other hand, a large standard deviation means that the data is more spread out, resulting in a flatter and wider bell curve. This indicates greater variability, with data points differing significantly from the mean. For instance, if we are looking at the exam scores of two different classes, both having an average score of 70%, the standard deviation can tell us more about the performance of the students in each class. The class with a smaller standard deviation would indicate that most students scored close to 70%. This means that the students' scores are more consistent, and there is less variation in their performance. In contrast, the class with a larger standard deviation suggests a wider range of scores, with some students scoring much higher or lower than the average. This indicates more variability in the students' performance, with a greater difference between the highest and lowest scores. Standard deviation is a powerful tool in statistics as it helps us understand the consistency and variability within a dataset. By analyzing the standard deviation, we can gain insights into the reliability and predictability of the data. It allows us to compare different groups, identify outliers, and make more informed interpretations of data based on its spread and distribution. Understanding standard deviation is essential for making accurate predictions and decisions based on statistical data. Normal distribution is not just a theoretical concept confined to textbooks. It has widespread applications in various fields. From finance and healthcare to manufacturing and social sciences, understanding normal distribution is crucial for making sense of data and drawing meaningful conclusions. In finance, for example, normal distribution is used to model stock prices and assess risk. By understanding the distribution of returns, investors can make informed decisions about portfolio allocation and risk management. Similarly, in healthcare, normal distribution helps analyze patient data, track the spread of diseases, and evaluate the effectiveness of treatments. Manufacturing industries rely on normal distribution for quality control. By analyzing the distribution of product measurements, they can identify deviations from standards and ensure consistent product quality. Social scientists use normal distribution to understand demographic trends, analyze survey data, and study social phenomena like income inequality and voting patterns. The prevalence of normal distribution in these diverse fields highlights its significance as a fundamental statistical tool. By recognizing patterns of normal distribution in real-world data, we can apply statistical models, make accurate predictions, and gain valuable insights into complex phenomena across various domains.